Hello my dear students, how are you all? Hope you all are fine over there. Welcome to our physics class. In the previous session we had discussed about Newton's first law of motion and also we discussed about inertia. Today we will discuss Newton's second law and third law of motion. Newton's first law was based on a new concept of inertia. Similarly, Newton's second law of motion is based on the concept of momentum. You might have heard this word momentum several times in your daily life. Okay, so today we are discussing more about momentum in physics. Also, we will discuss some of the important applications of Newton's second law and third law of motion. So let's get started with today's session, my dear children. Okay children, so let's continue with the lesson, force and laws of motion. The first law of motion indicated that when an unbalanced external force acts on an object, its velocity changes. That is, the object gets an acceleration. Whenever velocity changes, the object will be accelerated. Now we would like to know how this acceleration of an object depends on the force, or how can we measure a force. Okay. So that is obtained from the Newton's second law of motion. Before discussing about Newton's second law of motion, you must know what is momentum. So to understand momentum, let us recount some observations from our everyday life. Children, during the game of table tennis, if the ball hits a player, it does not hurt him, isn't it? On the other hand, when a fast-moving cricket ball hits a spectator, it may hurt him. A truck at rest does not require any attention when parked along a roadside. But a moving truck, even at low speeds, may kill a person standing in its path. On the other hand, a small mass such as a bullet may kill a person when fired from a gun, isn't it? But at the same time, when this bullet is simply thrown to a person from our hand, it is not going to hurt that person. So these observations suggest that the impact produced by the objects depends on their mass and velocity. Isn't it? In the case of the truck, if the truck was at rest, it does not hurt any person. That means the impact produced by that truck is zero. But at the same time, when the truck starts to move, even at low speeds, it can or it may kill a person. That means it can produce an impact on other object or on other person. So there, the impact produced by the objects depends on the velocity. When the velocity was zero, impact was zero. When the velocity increases, impact produced also increases. Again, if you consider the case of tennis ball and the cricket ball. In the case of table tennis, the ball does not hurt the player. But in the game of that cricket ball, the fast-moving cricket ball can hurt a spectator. So again, there is a difference in mass between tennis ball and cricket ball. Cricket ball is massive than the tennis ball. Okay, so the impact that can be produced by a moving object depends upon the mass of the object too. Massive cricket ball can produce more impact. And do you know what is this impact? This impact is known as momentum. Okay. So, what is momentum? So, what is momentum? Momentum is the impact produced by a moving object on another object. And this momentum depends upon mass and velocity. Okay, from the examples that I have cited here, it is very clear that the impact produced by the objects depends on their mass and velocity. So if an object is to be accelerated, a greater force is required to give a greater velocity. So there is some quantity that combines the object's mass and velocity, and that quantity is momentum. One such property that combines the mass and velocity of an object is momentum. Okay, and momentum is defined as the product of mass and velocity, because momentum depends on mass and velocity, and it is denoted by the letter small p. And what is the equation to find out momentum? Momentum P equal to mv, where m is the mass and v is the velocity of the object. Okay, this equation is very important. So what is the equation to find out momentum? Momentum P is equal to mass into velocity mv. And momentum is a vector quantity. So why is it vector quantity? Because momentum is equal to mass into velocity, and velocity is a vector quantity. Mass is a scalar. So momentum is a vector quantity. That means it has both magnitude and direction. So how will you find out the direction of momentum? The direction of momentum is same as that of the velocity of the object. If velocity of the object acts towards right, then momentum of the object also points towards right. Okay. Children, now we can state the Newton's second law of motion. So this is the statement. Second law states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. That means the rate of change of momentum is directly proportional to the force. So let me discuss, or let me explain the law with the help of a daily life situation. Okay, let us consider a situation in which a car with a dead battery is to be pushed along a straight road, because the car's battery is dead. If we want to start its engine, it needs to acquire a speed of at least 1 meter per second. For that, we need to push that car. Okay. So this is the situation. This is our car. Just suppose it is our car. Okay, I'm not a authentic person in drawing, so please excuse me. So this is the car, and suppose one person is giving a sudden push to the car. So the car does not start. So two persons started to push the car. So the car moved to some extent. Again, it was a sudden push. So it was not sufficient to start the engine of the car. Then they decided to push the car continuously for some time. Suddenly, the engine started. Okay, so there was a gradual acceleration of the car to the speed of 1 meter per second. So here what happened? When one person pushed the car, that force was not enough to start the engine or to change or to increase the velocity of the car. Two persons need to push the car. Again, they need to push the car for some period of time. So the time for which the force was applied is also important. Okay, so here the change in velocity depends upon two factors. One, the force applied on the car, and also the time for which the force was applied. Here, there was a change in velocity. Initially, the car was at rest. Then, the car was accelerated to a speed of 1 meter per second. So, whenever there is a change in velocity, there will be a change in momentum too. Why? Because momentum P is equal to mass into velocity. Mass of the car remains the same. It's not going to change in any of the situation. But velocity will change. So if velocity changes, since momentum is directly proportional to velocity, momentum will also change. So whenever there is a change in velocity, there will be momentum also. And there will be change in momentum. And that change in momentum depends upon two factors. What are the factors? The force applied on the car and also the time for which the force was applied. Okay, so the change in momentum we can denote by delta P, or let it be change in momentum itself. Okay, so the change in momentum depends upon two factors: the force applied on the car and the time for which the force was applied. Okay, now how can we represent the change in momentum? Suppose the initial velocity of the car, let it be u, and the final velocity of the car, let it be v, and the time for which the force was applied on the car, let it be t. Now how will you denote the change in velocity? Change in velocity is v minus u. So how will you denote the change in momentum? Initial momentum of the car is mu, because initial velocity is u, so momentum is mass into velocity. So initial momentum pi is mu. And what will be the final momentum? Final momentum will be mass into final velocity, and here final velocity is v. So if final momentum pf is m into v. Then how can we denote the change in momentum? Change in momentum is pf final momentum minus initial momentum. That is equal to mv minus mu. That is equal to m into v minus u. Isn't it? So this is the change in momentum, m into v minus u. And as per our previous discussion, this change in momentum depends upon two factors. First is the force applied and also the time for which the force was applied. Now bring this t to this side, to LHS part. So you will get m into v minus u by t is proportional to the force. And m into v minus u by t is change in momentum divided by time. If we divide any quantity by time, we will get its rate. So change in momentum by time can be considered as rate of change of momentum, isn't it? So the rate of change of momentum, m into v minus u by t, is directly proportional to f. And to remove this proportionality symbol, we can add a constant here. And the constant added here is k. Okay, so the constant is k, so we can write k into f. Okay, so this is the statement for Newton's second law. Experimentally, the value of k is found to be 1. Okay, so what is the expression now? Expression is m into v minus u by t equal to f. This is the expression. And what is the quantity on LHS? On the LHS we have m into v minus u by t. M into v minus u is change in momentum divided by time, that is rate of change of momentum. So on the LHS we have rate of change of momentum, and on the RHS part we have the force. So the rate of change of momentum is proportional to the force applied on it. So this is the statement for Newton's second law of motion. This is the statement for Newton's second law of motion. And again we can bring about some modifications. That is, we got this expression m into v minus u by t is equal to f. So what is v minus u by t? V minus u by t is change in velocity by time. What is change in velocity by time? Change in velocity by time is our acceleration a. So we can write this expression as m into a is equal to f, or we can write that is f is equal to m a. Okay, so this is the famous Newton's second law. Force is equal to mass into acceleration. F is equal to ma, and you must remember this expression always. Okay, so the force F is equal to mass into acceleration. This is the statement, or this is the mathematical expression for Newton's second law. So Newton's second law is simply F is equal to ma, mass into acceleration. And from this expression it is very clear, acceleration A is equal to F by m. Acceleration A is equal to F by m. So if mass is less, acceleration will be more. Acceleration is inversely proportional to mass of the object. Less massive objects change its velocity faster than more massive objects, so its acceleration will be more. And what is the unit of force? It's very easy to find out the unit of force. Force is mass into acceleration. So mass is kilogram, acceleration unit is meter per second square. So the unit of force is kilogram meter per second square. And another unit or another name for kilogram meter per second square is Newton. Okay, Newton, N. So the unit of force is Newton or N or kilogram meter per second square. N is the symbol for Newton. Okay, so this is Newton's second law of motion. And there are so many applications of Newton's second law. The second law of motion is often seen in action in our everyday life. Okay, see, many applications are cited here. When we kick a ball, we exert force in a specific direction, which is the direction in which it will travel. In addition, the stronger the ball is kicked, the stronger the force we put on it, and the further away it will travel, because F is equal to ma. So if force is greater, the acceleration produced will also be greater. So the stronger the ball is kicked, the stronger will be the force applied, and further away it will travel. That means the acceleration will be more. And it is easier to push an empty cart in a supermarket than it is to push a loaded one. Why? Because the mass of empty cart is less than that of mass of a loaded one. So if mass is less, acceleration produced will be more. So more mass requires more force to accelerate. Now, among the two people walking, if one is heavier than the other, then the one weighing heavier will walk slower, because the acceleration of the person weighing lighter will be greater. Okay. Then, in Formula 1 racing, the engineers tried to keep the mass of the cars as low as possible, because low mass will imply more acceleration. And more the acceleration, the chances to win the race are higher. Next application. Pushing a car is easier than pushing a truck with the same amount of force, as the mass of the car is lesser than the mass of the truck. In golf game, acceleration of the golf ball is directly proportional to the force with which it is hit by the golf stick. Also, the force applied is inversely proportional to the mass of the ball. Okay. Next, application of the Newton's second law of motion is shown on the screen. You might have noticed, while catching a fast-moving cricket ball, a fielder in the ground gradually pulls his hands backwards with the moving ball, like this. Have you noticed that? Okay. In doing so, the fielder increases the time during which the high velocity of the moving ball decreases to 0. Okay. Otherwise, what will happen? The car will suddenly come, the ball will suddenly come to rest in the fielder hand. That means the time taken by the ball to come to rest will be more. And as per this equation, when the time taken is less, then the force applied will be more, or the force exerted will be more. So the more force is exerted by the ball on the fielder's hand, and which will hurt him. But at the same time, when he lowers his hands backwards while catching the ball, a little bit of time, more time is taken to change the velocity of the ball, much more time is taken by the ball to come to rest. So as per this equation, the time taken is more. So whenever time taken is more, force exerted will be less, because force is inversely proportional to time, and less forces exerted by the ball on the fielder's hand. Okay, so this is the most important application, and this application is there in your NCERT textbook too. Okay, so the fielder increases the time during which the high velocity of the moving ball decreases to 0, and thus the acceleration of the ball is decreased, and therefore the impact of catching the fast moving ball is also reduced. But if the ball is stopped suddenly, its high velocity decreases to 0 in a very short interval of time. The ball comes to rest suddenly. So the rate of change of momentum of the ball will be large, and therefore a large force will be exerted by the ball that may hurt the palm of the fielder. And similarly, in a high jump athletic event, the athletes are made to fall either on a cushioned bed or a sand bed. Okay, this is to increase the time of the athlete's fall to stop after making the jump. Okay, otherwise what will happen if there is no sand bed or cushion bed? The athlete falls to the ground, and directly to the ground, and he or she comes to rest suddenly. So the rate of change of momentum will be more, and the force exerted also will be more. So the impact of the jump will be more. But at the same time, if there is a cushion bed or sand bed, it will take much time for the athlete to come to rest. So the rate of change of momentum will be less, and the force exerted also will be less. Okay. So all these are applications of Newton's second law of motion.